computers will do things in domains that we thought were only the domain of humans. They'll do them better than we do. And I don't think that's catastrophic. It's not about regulating AI. It's about regulating the use of AI in particular domains. I think we're going to think about what it means to be human as these systems do more for us.
If you wonder how to deploy data science and data-driven AI and what things to consider beyond technical aspects, stay tuned. Today, I'm talking with Dr. Alfred Spector, a visiting scholar at MIT and senior advisor at Blackstone, and also a co-author of the Data Science and Context: Foundations, Challenges, Opportunities book. This is an hour of innovation, the podcast where we explore innovations and unique approaches to solving challenges. Welcome, Alfred. Thank you for joining me today.
Good. Thank you very much for having me. I look forward to our discussion.
Great. Yeah, me too. So why don't we start with the book? And I just wanted to ask, what motivated you and your co-authors to write this book? Is there any problem or gap that you were trying to fill in?
Yeah, absolutely. It's why we were motivated to write the book, is we thought that over many years, people were primarily interested in what's the model? What's the new AI machine learning algorithm? What's the new statistical technique? That was where all the excitement was. But what those of us that had been in the field for a long time knew is it wasn't just that. That's important, right? We're excited to have foundation models and all of the new innovations that have occurred over the last roughly 15 years. But there's so much more. If you're going to build an AI application that's really valuable across many dimensions, or if you're going to use data science and statistics to generate a result that, if you will, casts light on a problem rather than just more heat. Mm-hmm. So we felt that it was important to go beyond another textbook in statistics or another textbook in machine learning. Those are very important. But to try to integrate everything else that someone who is pursuing new applications, the regulation of applications, the evaluation of applications, considerations of the use of AI, data science, what did they need to know?
Okay, I see. So step back a little bit. What is a data science?
Well, so I think it's a great question. It's a new term. So 2010 is when you saw the staircase phenomenon and when that term started to become used. And it's not been well defined. So we had to put our pencils to paper to do that. First, I mean, the thing that Jeanette Wing, co-author Wing, said, Professor Wing, said that she had always felt it was fundamentally about gaining value from data. And that's true. But in a sense, it doesn't mean that much to people. What does it mean to gather value from data? We look at an alarm clock when it goes off in the morning and say, it's 7:15, I better get up. I just gathered value from data. That's sort of not what we mean. Mm-hmm. So what we thought about was we really wanted to provide a definition that captured the two kind of personalities of data science. So one of them is that we provide insight to people, usually from fairly large collections, not always, but usually fairly large collections of data. So can people sort of intuit a possible model that explains what's going on? Do they gain some new understanding of a problem that they wouldn't have understood without having data presented to them in a useful and comprehensive fashion? So that's the insight notion of data science. So I think that you're involved in biomedical work. It's what we always want to have when we're doing studies on drugs and such things. Can we find out that there's some likely value in a certain treatment? The second is increasingly we're using data science and in fact AI to generate automated conclusions. So what we want is we may want a prediction of some variety. We may want a recommendation of what to listen to or what to see or what to do, etc. We might want some clustering of information that is in one category or another, like spam. We'd like to cluster spam together. We might like to give names to things, right? We want to develop a naming structure for things. So there are a set of 6 or 7 uses that are the typical uses of these systems, and we think those are worth calling up, and we do that.
Yeah. Okay, that's great. that creates some sort of understanding what it means in this context.
And one
And
other
then
thing,
also,
just in it, so there's an aspect of it, not to interrupt you, but there's an aspect that's sort of more traditionally statistical in nature. And that's more traditionally the insight notion. And there we'd often use, graphs to show information to people and such, and look at statistical confidence intervals and such things, and maybe deal with issues of causality and such. And the other is more what we see on the web and more what we see with AI today. And that is, I'd like you to predict the next word, or I'd like you to transform this audio signal, which is, a variety of phonemes and sounds and such things, into text, or maybe English into another language, etc. So that's the reason, is we think there are 2 personalities to the field.
Yeah, and then my next question would be, how does data science related to artificial intelligence? And I think you kind of started mentioning this a little bit already.
Yeah, right. So I think certainly the AI world is definitely more on the automated conclusion side of things. So it's definitely more there. I think operationally, both fields use machine learning a lot these days, but they go beyond it. So AI will do, we consider robotics to be part of AI, I think, these days. So there you're obviously concerned about mechanical engineering and control theory algorithms and such things. And in data science, we might care about visualization algorithms more than we would naturally do with AI. And so the problem domains are somewhat different, but overlapping. And then I think the technologies that are used are, again, overlapping. Like we care about privacy in AI, we care about privacy now, of course, in data science. We care about security in these systems because they're pretty powerful and people may want to break them for bad reasons. So we care about some things in common beyond machine learning, but then there are things that are different.
Yeah, and how does data science and artificial intelligence evolve in the recent years beyond the tech aspects? Like you mentioned the policies, you mentioned maybe there is something ethics, things like that.
Yeah, so I think it's kind of like this. I mean, we don't say it quite this way in the book, but I think it's true. So in the earliest days of data science and AI, all of us, I think researchers and such, with the new big data realm that we had and these new machine learning algorithms, we were just seeing if we could do almost anything, right? So like the earliest machine learning algorithms were used for looking up and identifying zip codes and addresses in mail. So we're trying to see if neural networks would do a better job of doing digit recognition. In fact, they were. So we had very simple problems that were not that hard to figure out what our goals were. There were no real privacy issues in doing zip code recognition. And, if you made a mistake, it would maybe be checked by a human who would look at it very quickly. So the problems were sort of forgiven. And in many cases, even as these systems became more powerful, they were sort of innately forgiving problems like advertising recommendations. So machine learning, call it AI, call it machine learning, call it data science, whatever you wish, advertising was heavily based on these techniques, even, in the 2000s and the 2000 to 2010 period. And it was fine because what if you showed an advertisement that wasn't perfect? It wasn't the end of the world. Now what's happening is we're thinking about the applications of AI in every sector of the economy, the applications of automating recommendations or conclusions or optimizations or, all these things in every sector. And they're important. If we think about it in education, Are we expanding the opportunities for children based upon their capabilities, or are we restricting them in some way because we're extrapolating from too little information and maybe restricting what a child is capable of doing? These are very important issues to get right. So I think the bigger difference now is that we're not just playing anymore. We're not dealing with simple problems. We're dealing with among the most fundamentally challenging problems, like how to educate our children properly. We're dealing with those problems, and that necessitates a broader perspective.
Yeah. And then in the book, you're also describing analysis rubric, which has like 7 elements to it.
Right.
What kind of challenges and problems it aims to overcome?
Well, so first, let me just, if I can just stop for a second and say, why do you need a rubric? What's a rubric for? What is a rubric? It's not exactly a word we use in language every day.
Sure. Yeah.
So I think a rubric is there so that you don't miss things, right? So a physician might have, when doing differential diagnosis, a list of things, questions to ask to make sure that physician doesn't miss anything, and goes through a list of possible symptoms and their implications in sort of the best possible order. So that's a kind of a rubric or a checklist, as Atul Gawande, a very famous doctor and a physician, I think, out of Boston, writes about in a book called The Checklist Manifesto. And of course, if you're an airplane pilot, you do the same thing, right? You want to make sure the wheels have enough air in them and the fuel is balanced in the tanks in the proper way, and is enough fuel, and all the other things, because you don't want to take off with a mistake. So you really want a checklist, and then it's very clear: do we have the right amount of fuel? Is it balanced, etc. So with data science and AI, what we feel is there are a list of questions we have to ask in order to be reasonably certain we've thought through the issues in building a good application of these systems. And there are 7 elements that we have to consider. Now, it's not yes or no. Did I do it right or not? Is it needed or not? It's, did I consider it? So it's a rubric more than a checklist. I think that's the sort of connotation of rubric. So the first is there data? So there isn't always data. Like we learned, I think, when trying to do this understanding of person-to-person transmission of COVID, that we didn't have enough data to do it, right? We didn't know exactly how close people were, what direction the wind was going, were they extemporizing and breathing hard like they were singing or, at a dance together, or were they just sitting quietly? You have to know an awful lot to really understand the likelihood of infection of one person to another. So trying to do that proved very difficult in the United States for sure, but really everywhere. Yeah. So we've made some efforts, but that's not a place where you could get the data. And frankly, the data was problematic. People didn't necessarily want that amount of somewhat invasive personal data. Who was I with? How close was I to that individual? You can imagine the challenges in this society, and frankly, any society, for having enough data for that. I would say in the earliest days of data science, everyone just said, well, we'll just capture all the data. We'll capture everything, and we'll figure out what to do with it later. And now we've realized that's kind of hard. It's dangerous. It's risky. There's risks of having too much data. So should we have the data? Can we have the data? What's the cost of it, etc.? That's part one. Part two, is there a model? Is it possible to get the kind of answers that we want? So there aren't models for everything. It would be nice, right? But, we're talking just before a presidential election. I don't think there's a model that anyone believes with very high likelihood will predict the result of the next election. It's kind of close. So statistics and such have all sorts of sampling errors and things that are extremely hard to correct for. So there really isn't a model that will give a very reliable conclusion on that. That's what all the pollsters are telling us. No. There are many more things. Can we predict interest rates at the end of 2025 in the United States? 30-year Treasury bill rates? No, we can't. We don't know. There are too many variables. And other kinds of things make modeling hard. There are sort of changing distributions over time. What's right in the winter might not be right in the summer. People don't buy mittens in the summer in the United States, they buy them in the winter. So if we were trying to predict off one period of time without understanding the variability in distributions and such, you'd make a mistake. So modeling is quite tricky to get right. Now, in the case of periodicity in it, we probably can get that right. But then when there's game theory involved, if I say something and then you try to counter that and I try to counter you, that gets much, much harder to predict. So that's the second. Is there a model? The third is, can we make the system dependable? What we mean by that is this is a set of 4 topics is what we include in dependability. And the first is, can we vouchsafe the needed privacy characteristics that the community of users and society will want? So, for example, in healthcare, we'd like to learn an enormous amount about data, but we also don't want all the information on individuals to be made public. And that's always the extremely hard and difficult problem that folks everywhere have to work on in that space. It makes things much more difficult to do. What do we even mean by privacy? We talk about that in this rubric. Is privacy just the maintenance of confidentiality on data? Could be, but people may be concerned more with that. If data is used in ways that they view as intrusive to themselves or overly influential or coercive, even if no one knows it, the individual might say, you're using my private data in ways that I am not sure is helpful for me, in ways that are helpful to me. So there are many topics. In general, what we advocate is that people should be very careful to define what they mean when they're talking about privacy, or they'll talk past each other. So that's the first, right, of these topics in dependability. The second is security. So will a system work properly when it's supposed to? Will it abide by the necessary rules? Will it be free from attack by bad guys? And these systems are now very important, right? They're going to be running the nation's fleet of automobiles within some number of years. And that's a pretty big attack if someone attacked that system and stopped all the automobiles from moving. A third is the question of what we call abuse. And that's just in the normal course of operation, will people abuse the system in some way? So, for example, in the vSafe program, which was a sort of post-vaccine monitoring system that was set forth by the United States government in the realm of COVID, some people kind of wanted to cause trouble about the efficacy of vaccines, and they entered reactions to vaccines that weren't valid, kind of to scare other people from taking vaccines. So that's an abuse issue. It's kind of a security issue, but it's kind of in some ways, a simple security issue because end users can go and do that. And then finally, we do have to be humble. Are these systems resilient? Will they be resilient? Because things change, right? We have to, if we build a system that's so perfectly tuned and we're just sure we got everything right, that's probably a recipe for disaster because, the world is going to change. The mere deployment of a system often changes the world around it. So it has to be more resilient. So that's the first 3. Is that okay to keep going, Vit? Or that's 3 of the 7.
Yeah, that's fine. Let's list them all. Yeah.
Okay, so then the next ones take a little bit less time to discuss, fortunately for you and our audience. The fourth one is, does the application need to be what we say understandable? And that can be also breaks down into a few categories. So the first is, you have to be able to explain to someone why it provides a certain recommendation or answer, a certain conclusion in our terminology. Second is, you have to be able to explain to the developers why it's working. Does it need to be interpretable to them? And third is, will it need post facto to be auditable? so that auditors could look at it, regulators, sleuths, someone could say, I looked at that system, looked at Alfred's system, and yes, it was doing what he said it was going to do or what it needed to do from a regulatory perspective. Audit's an interesting idea. I think it may be overly pushed because there's a lot of dangers in audit. We can get back to that. Second is, in understandability, is does it have to show causality? So it's not so hard in many instances of data science and AI to say, look at the relationships between these things. They're remarkably consistent. There's correlation. But does that mean there's causation? And causality is very important, particularly in research domains, but really for our understanding of public policy, what the impact of a policy is on some segment of society. So causality is often misinterpreted. It's too easy to see correlation, and even for experts to make a mistake and say there's a causal relationship when there isn't.
Yeah.
And many people have a vested interest in showing causality when there isn't such. And then the third in characteristic is does something have to be reproducible? And does it have to actually be able to produce a scientific result that's reproducible by another scientist? So that usually means making the data available and the model available. And the data may be private, and the model actually, frankly, is so complicated and big, it may change over time. If we're using a foundation model, they're continually changing on the web. So it's hard to do the traditional notions of scientific reproducibility. And one that my MIT students in my class last semester came up with, a new idea here, is transferability. Should a system actually be teaching its users, its user community in the world, what it's doing so that they become more educated? So like even if in a self-driving car or even a navigation system, I guess, on a regular car, should it be telling us, hey, here's why we're going this way? Because at this hour of the night, the George Washington Bridge is really crowded, or whatever it might be, would be better to go this way. Probably good. It should be doing that. Why should we humans be not taught by these systems? The next one is, what are the objectives of a system? So do we know what we're really trying to achieve? Now, sometimes we do. Sometimes it's pretty clear. But other times it's not so clear. So even take a simple application like music recommendations, which there are many models at work. And we need it, right? Because there are millions of songs available to listen to. We need something that will help us get through all of that. But should we be recommended things we've never listened to before to expand our minds? Or do we need something soothing, maybe something that we know and soothing? Or are we falling asleep and we want something else? It's a tricky problem as to what to do. And of course, in news, it becomes even more complicated because then matters of politics and balance become in there. And in some matters of society, there are notions of economic optimization versus optimization for fairness, and many, many more topics. We write a lot about it. And I think Peter Norvig and I were talking at the AI conference just a month ago, which posted a LinkedIn piece on it. Excuse me. And in that, we noted that we think this issue of setting the right objective is going to be a bigger and bigger problem as these systems move into broader domains of use. The last one is of the first six, and then there's a seventh one that's special. And the sixth one is, if the application's sort of failure tolerant, it's fairly easy to do. And if it's not, then it's much harder because these algorithms are stochastic. Nothing's perfect. We're not using a sorting algorithm, which would have been guaranteed to put things in lexicographic order. Now these things are saying, with probability that's quite high, we'll give you a good answer. And that's all we can expect. And if the systems are matters of life and death, that's problematic. It might be okay, but we better think about it. So we have to think through that rubric element, is how failure tolerant. Now, given all of this, and we can discuss this later, now we have balancing questions. How do we balance the complexity of the application and its cost versus its perfection in some domain? How do we balance efficiency versus issues of equity? How do we balance privacy and security? And many topics like that. Some of them are legally mandated. Some of them seem to be ethics issues. Some of them are economic issues. Some of them require some perspective on history to understand what's happened before. And we argue that's sort of the seventh element in the rubric is think through the issues that will help you balance this. So we believe if you do those 7 topics, and anyone that listens to this, you can apply this to your domain where you apply AI and data science and see if it makes sense. And we're not arguing you have to be perfect at anything. We're arguing you have to think about it.
Yeah. No, this is a great rubric for doing this. And actually, in my previous job, we were building auditing systems for much simpler things like restaurant checklist or hotels or maybe job safety things. They were sometimes complicated. We had some complicated audits to do with hundreds of questions and things like that. But people who were in this industry and they were creating all these things, they were thinking about kind of very similar to this, like security or ethics or some other areas. Multiple areas of the business were included in those type checklists. So that's very commonalities are there. But then,
Yes, that makes sense, right? I mean, that's the thought. So
yeah,
it will be different in different places. So, for example, if we're doing work on more of the insight personality of data science, then we're looking at, what level of statistical significance do we need to have? Are we, trying to show causality? If so, how can we minimize the expense of natural experiments to demonstrate this? Is it worth it? What's the probability of success versus? So lots of issues go into this, and we think they're captured by the rubric.
Yeah. So I guess my next question would be, if we talk about like a real life example and somebody trying to apply this rubric to them, they should go through all these elements and evaluate for their own case, for their own product, which parts make sense, which parts don't make sense, and kind of double check with themselves if they're doing things correctly, right? Is that kind of the intent?
Right, I think that's correct. So, and what we advocate is that we're honest about the evaluation on each rubric element. So we can say, look, here's what we know about privacy, right? We're pretty sure, we've thought it through. We have an open question about this. What if someone could possibly get this? Could they combine it? So we need to express that, right? We need to say that. And here's where we've gotten to. And then when we balance, well, this application would be incredibly valuable because this could be a cornerstone in understanding what causal phenomena cause a certain kinds of cancer. Then you could make a risk-reward decision on that very small risk that might exist versus the potential benefit that you're getting. And I think those are the kinds of things that we need to have. I would say my co-authors and I don't think there is an absolutism in this that you can just say, because nothing is really perfect.
Yeah.
It's not as easy as computing payroll for someone, which is an easy computing problem.
Yeah, and I think it's also important that, as we mentioned, as things evolve and products evolve and user needs come, new user needs come, these things can change, and you may add or remove things from your decision-making
So,
process.
I mean, I'll give you an example. So when we were doing at the Google Corporation a long time ago, automated directions in Google Maps, initially, everyone kind of felt, well, gee, it's sort of an obvious objective function. Right? You're trying to minimize the time from point A to point B. How could this be bad? Right? Everyone would benefit, right? You'd save time driving, you'd probably use less fuel, right? You'd maximize, if you're minimizing congestion on roads, you're probably minimizing you're maximizing the capacity of the road network by routing people away from traffic jams. It seemed like a perfectly good thing. Now, as you roll it out more, things change, right? You realize, oh, I'm routing people on little country roads that the inhabitants used to think were really quiet. So the people using the system are happy, but the people that they're driving by are feeling put upon by increased traffic. That happened. And then you realize, well, are we trying to optimize time? Are we trying to optimize pleasure? Maybe some roads are prettier and nicer to drive on. And then you learn, well, what about safety? Some roads are more dangerous than others, and people have different thresholds for this. And I'm not sure exactly, for myself or you or any of our listeners, we're really late for something and the risk is pretty low. Do we go a little faster and take a little more risk, or go a safer? It's a complicated issue, not an easy one for a route finding system, part of a big tech company, to make a universal decision. And it goes on and on like that. There are many more. Even one more is, if you do this now and everyone is used to a route finding system and they need that direction finding, it becomes ever more important and riskier if the system were to go down, because the public has become dependent upon it. So that just innately changes. That's a sort of resilience issue. You might say, well, if it went down 5 minutes a day, people lived without route finding for all of eternity, they could live without it for 5 minutes. Maybe not in 30 years, if the public is not spending so much time on understanding the intricacies of road networks. And you're in Greater Washington, I'm in Greater New York. They're complicated. Maybe they're better things with human time than doing that, and we stop doing it.
Yeah,
things change.
Yeah, things change. And I was thinking with this example of myself driving, I sometimes don't listen to GPS. I just sometimes go my own way and kind of break that system that Google presented to me.
Well, this leads to a question on objectives.
Yeah.
So if your objective is to get somewhere as fast as possible and to minimize the need to pay attention, a route finding system is good. Realize that you as a driver are reduced to turning the steering wheel in response to directions from some, we'd say now, AI in the sky that knows everything.
Yeah.
Maybe you don't like that as a human being. Maybe you say, my fundamental humanity is that I like understanding the game of rush hour traffic on the Washington Beltway and how to avoid or benefit from that in some way. And that's really an interesting problem. So we do have to think about the impact of these technologies on humanity. If you're a baseball player and and the system says you need to hit to, left field here because we know the details of this player, now you're just sort of reduced to being someone that's good at hitting. You don't have to play the game strategy so much. So I think we're going to think about what it means to be human as these systems do more for us. So don't get the view that I'm someone that's all worried about automation and I think it may be bad and we should all go back to the good old days when we did everything for ourselves. No, washing machines are a great idea. Generative AI is a great idea. Will solve all sorts of problems and make us more creative and more efficient. And I think will generate all sorts of new advances based on this. But that still says we need to think about these issues and balance things in ways that work.
Yeah. That's true. I agree. I think there's huge potential in that. So more things to come, I guess, and it's exciting times.
It's very exciting times.
Yeah. So the next thing is there is a 3-part framework for decision making that you described. And this rubric is actually step 1 in this 3-step or 3-part framework.
Right.
What are the other 2 steps? Right. And what is the purpose of this framework in general?
Well, so here's where so you asked, why did we think about the book? And I'll tell you why I thought, and I explained that we thought people were often missing what were the really hard parts of problems. In the rubric, in sort of the 3-part framework paper that I wrote, I was trying to think about this big question that we have many things to balance as we deploy problems that are addressing increasingly the fundamentally interesting questions of civilization, of humans operating in the real world, the questions that the ancient Greeks brought up and that discussed by the Romans and have been discussed in the Renaissance and by sort of all cultures around the world in different ways. So the issue was, could we as scientists answer these questions as purely scientific? And I think the answer is sometimes no. In fact, more often than not, no. So scientists can say, well, there's a sort of a Pareto envelope. There's something that we could do where we can improve this and we can improve that, and they're both improved. And that's better, right? If we know that they're improved and we can improve both things. But usually if we improve one thing, something else is a little worse. Or often that's the case. So we have many dimensions to this now. And we can't make the decision of how to balance all of these individual items. So just as an example, just take a very simple one. You can imagine a watch that's helping people exercise, right? It's a good thing, right? It's giving them goals and it's whatever. Now, how much does it really need to know about the weather? Does it need to know it's warm out today and that that's dangerous perhaps to a certain population segment and should cut down on the amount of goal setting that it's doing? Perhaps. Does it need to know the recent electrocardiograms of the runners involved? Because you could do machine learning based on that and probably have a better way of predicting risk of heart problems from exercise. And the list goes on. How do you get that right? Right? You could go forever and never ship a product and do no benefit. Same issue will come as how safe do safe driving cars have to be before we're really happy with them. They have to be perfect. If they have to be perfect, we'll never deploy them.
Yeah.
They have to be very good, but how good is good? So these are the sorts of questions. And I think societies are going to decide these in different ways. What might be right in this society in America in the year 2024 might be different in Europe, which might be more safety conscious, say. Might be different in China, which has a stronger view on coherent national thought, for sure. So there are going to be a variety of things. So the question is, how do you think about this? So number one, the rubric is neutral on a bunch of topics. It says, consider safety, characterize it, characterize dependability, explain what you mean by it having a certain amount of reliability. Think about privacy. Think about what your objectives are. Be able to clearly define them. Second thing we say now is, all right, it should be obvious, but I'm afraid it's not. Let's be scrupulously honest in our characterization. And we have seen in, obviously, contemporary politics, we've seen in, I would say, in public reporting, and we've even seen among scientists sort of egregious errors of honesty and integrity in that. And we've seen it among top scientists that have made what even seem to be, in many cases, deliberate errors. But even when they're not, certainly there will be mistakes made. I understand that. But we should really go out of our way on big issues that are affecting health of people and societal wealth and such issues to be very honest, even if it means it takes longer to do the work. And I think it does. But we have to be honest or we'll lose all credibility. When people during COVID made pronouncements that seemed simple to the public and they weren't exactly right, it's generated huge amounts of distrust now in the public health system in the country. So that proved to be a mistake. And I think we have to be careful. So integrity or honesty is the second bullet. And I, in my classes, remind people of that. And I would urge all of our listeners to both be really careful ourselves. It's easy to be optimistic and say, well, that's probably right. Let's be really, really rigorous. And then in addition, when we're educators and managers and mentors, let's be careful to remind everyone. So then now we get to the final issue. So now we have truthful understanding of what we're doing in at least all the dimensions that I can think of, that the rubric selects, now we're going to balance issues. So how are we going to do it? I don't know the answer. I have my own political views on certain things, but that's only part of it, right? I'm one of 300 something million people in this country in terms of political views, and only one of 7 or 8 billion on the planet. So there are a variety of decisions that are going to get made in different ways. And all we can argue is that people should be careful to look through the set of issues that should govern us. So today there's a definite pulse, you feel it, that people say we need to do ethical AI. Well, I agree with that. Ethical is an important thing to consider. We don't all agree on what ethics means. Right? We don't agree on the relationship of individual rights versus collective responsibility. That's a big topic that John Stuart Mill wrote about, and you get different points of view from different philosophers on that topic. But those are things that we need to sort of have give and take on and reach conclusions on as we do certain kinds of systems. We can consider the Belmont principles, which are the principles that say that before we do something to someone, we should give them understanding, full disclosure of what it is, and the right to opt in or out of that. Right? So that's called respect for personhood in the Belmont principles. We should try to maximize the likelihood of benefits and minimize the risk of harm. Certainly, we should aim for fairness, aim for the broadest impact we can. So we benefit many people, not just a few. But even then, there are balances across that, right? There's a balance between different things. So, for example, vaccination. So, in vaccination, do you want to give kids in schools the right to opt out of measles vaccination, knowing that we don't get herd immunity and could get herd immunity with measles vaccination? It's very important. Or do you want to mandate that people get vaccinations? And if you do that, it benefits the whole class very effectively of minimizing what's actually a pretty bad sickness for kids. So that came up with COVID. It's come up again with measles. It happens in all sorts of data science arenas as well. So those are ethical issues, but there are more. So now it's the issues of politics are involved. How is this going to affect political systems? How is it going to affect great power relationships between countries? It would be nice if everyone was motivated in exactly the same way, but it doesn't seem to be the case.
Yeah.
So if one country decides they're going to have enormous conservatism on the application and deployment of artificial intelligence, and it means they're less economically powerful, that has implications in great power politics. So a third is, in fact, economics. You need to think about that. We have an economic system that's designed to cause people to be motivated to do exciting and new things and to work hard. And I personally believe that's an important and necessary thing. If we have lots of regulatory issues in this, it will have some impacts that are probably negative. So balancing that is an important thing. We need to look. So that was economics. That was political science. That was philosophy and ethics. I think we should be looking at history. Where have we been able to do things? Like, what's been the history of our ability to control nuclear energy? How has that worked right? How has it not worked right? What have we done properly? What haven't we done properly? We can learn from lots of things over time. And then the last thing I would argue, in fact, I was having a discussion this morning. I had breakfast with the former CIO of Google, and we were discussing the fact that the world's going to be very different, right? Whether AGI is there now or in 3 years or 20 years, it's going to happen. There's no question in my mind it will happen. So that world's going to be different. Fiction writers tell us about fictional worlds. This world will seem fictional to us. So if we go into this with blinders on and say everything's going to have to be the way it is today, we're going to be very disappointed. That's not going to work. We're going to be viewed as repressive and stultifying. we're going to have to be open to change. And I think fiction, not just science fiction, but fiction broadly allows us to explore human relationships and situations that haven't happened often, or that happen philosophically, not in detail. And we get a chance to think about those. And we'll need to do that because the world will be different.
Yeah, so I'm just thinking that this probably all makes sense to technical people or who are somehow involved in technology, or maybe not necessarily technology, but science also, even though it's kind of similar these days. What about, like you mentioned, people in liberal arts, for example, they probably less aware of this, maybe older generations less aware of this, maybe certain countries even less aware of this. Is there anything educational system or governments can do to help like educate public?
Well, I think it's very important. So I have two answers for you. So first is broadly, we in technology, what I was saying, need the liberal arts, right? These disciplines I were mentioning are classically called the liberal arts, right? So we need students today to be more knowledgeable and open to the breadth of the understanding of civilizations, to help guide us in the use of these ideas in the future. So, and just to finish that thought, when I was an undergraduate, I did take courses in the liberal arts, but to be frank, they weren't needed in the development of large-scale distributed file systems, or the kinds of things I worked on early in my career. As I got later in my career and these things got powerful, when I had decision-making authority at Google and IBM and at Two Sigma, they became much more valuable. But that was 20, 30 years later. So now it's even more so. So I very strongly advocate that our students in the technology sector spend some time reading history, taking history courses, learning something about political science, reading Machiavelli and other topics about how the world might work or shouldn't work or does work. It's all important. Now then, turning to the broader public education, I think that the need to understand data and computing, at least a little bit, is of necessity now for everyone. So in our book, even last week when I was speaking in last week or the week before, I forget, I guess it was last week in Denmark, I advocated that we need to have data science and sort of programming, simple programming, taught really to everyone now in the school systems. So I would infuse into most disciplines, starting at young ages, some notions of data science and scripting and such things. So it's always been the case that like maybe in middle school or you do some experiments, you drop balls from something and you measure how long it takes to hit and you learn Newton's law. Well, let's do it with some data. Let's have a little database. Let's track that. Let's do some regression to see things like that. Let's get used to the fact that there are going to be anomalies and bad data and such things. Let's use that as an opportunity to teach a little data science, not just physics. And let's do that in the social sciences. Let's use some of the tools in the humanities to understand the use of words in Shakespeare or in other things that students read. So I think we need to do that. I would also, for many students that are not going on in physics or in science or something, I would say that probably taking a senior level course in data science is more important than calculus. So I would say, and maybe more important than some other math courses. So infusing these sorts of discrete models into classes is pretty important. Last final point is I'm actually working on a paper with a noted humanist. And we're going to argue that from a professional practice point of view, the social scientists and humanists now need the technologists more than they ever did. So why is that? One, there are all these tools we're providing, right? So there's no question that we're providing research tools or writing tools. They're going to just get better. So they need our tools. And there were things like the Ngram viewer, which looked at word frequency over time, and the books corpus that was done when I was at Google. That was very interesting to literary and experts in language to look at how language changed over time. There are going to be an endless number of tools. So that's number one reason. Number two, I think they need it also because the mere availability of data today, just that availability of data on almost everything, changes the nature of what we know about our world. So it's been called nowcasting in economic terms, but it's really broader than that. We have information now that's unparalleled. I mean, 150 years ago or 170 years ago, before the invention of the telegraph, it took 2 months to get information back and forth from Europe. Now if one little thing happens in England, we know within a tenth of a second that it's happened, even if it's about one person in a remote village. So we have to understand how to use that information, how to put that in perspective as well. And then finally, I think the world, as I argued already, is going to be very variable in the future. It's going to be a lot of possible futures. And fiction writers and social scientists, and sociologists have a much broader world to contemplate than they would have 30 years ago. So I think they better start thinking about what's happening in the tech sector if they're not already.
Yeah. It's like in the past when people first got to literature, for example, or written, right? Everybody started learning how to write, and that was a huge jump in overall education and overall civilization, like graduated to the next level, basically. So I think we're experiencing something like that these days, when with AI and these enormous amounts of data we collect and we process, and it helps us with decisions and generative AI. It's the next big jump, and probably going to be the biggest by far. So
I agree. And I do think some people say, look, it's fundamentally different than the Industrial Revolution. And I think they're right. It is sort of fundamentally different. We were automating things, right? It's a big deal. Washing machines are a great invention, right? Think of the amount of time that has been saved in people's homes without having to manually scrub every article of clothing. So those were really big inventions and really good inventions, despite whatever issues they have with use of energy and such. Those have been, on the whole, very, very empowering to the public and such. But these will be different. But that isn't catastrophic. Computers will do things in domains that we thought were only the domain of humans. They'll do them better than we do. And I don't think that's catastrophic. I'm a very mediocre piano player. And there are many humans that play the piano much better than I do. And I still love to do it. So I think when a computer can play the piano better than I can, it won't be the end of the world.
Well, they can play better chess already and Go. So.
That's right. And we all play chess and Go still, right? It's perfectly fine. So I think we're going to find this is all fine, but I think it's going to be different. I already see, as I'm sure you and our listeners do, that there's situations with generative AI do better than we can do on something. I mean, I use some of the tools to correct my writing now, and not to write for me, but to correct writing. And they find little errors that I don't notice way faster than I do, and I view it as great.
Yeah, I use those all the time as well. Yeah, that's great. Okay, so we're almost at the end here, and in the last, I just wanted to ask you to provide an advice on something maybe we haven't talked about. You kind of had already recommendations and advices in what we discussed, but maybe something else that we haven't.
Yeah. So I guess what I'll try to do is summarize. Three things. So first is, I think that context is key, and that is a word in our book, Data Science and Context, and it's key for a number of reasons. One is the context around the model, right? The data, the dependability, the privacy and security, the objectives, the need for understandability, whether the system is failure tolerant or not. That context is very important in how we use AI and data science. Second, we have to realize the context of the application of AI and data science is very important to telling us what we need. So it's very different if we're using a foundation model like the new ones that Waymo says it has in self-driving cars than it is in generating poetry, right? It's a very different thing. One might be regulated, one has life and death issues associated with it. The other is sort of fun, and maybe actually hallucinations are a good thing if you're helping someone be creative. But third context uses society, right? The context is different here than it would bid thank God if this country was at war, right? It'd be a different set of contextual issues. There are ethical frameworks, jus in bello, jus ad bellum, that are about warfare that are different than the Belmont principles or talking about the harm principles of John Stuart Mill. So context matters in a societal perspective, not just an application perspective, and not just a technical perspective. And then I also have to think, we have to think about, as we brought up earlier, I think you brought it up, that there's a notion of time. Things change over time. The systems we introduce change the perception. For example, lots of people are concerned about facial recognition for privacy reasons. It's valid, all sorts of good reasons why there's risks in law enforcement and jurisprudence if facial recognition is not done in a balanced way. I've seen the use of facial recognition in checking people in the airlines now and getting through customs, and people love it. I mean, I saw this digital ID at the airport, and you just don't take anything out of your wallet. You don't fumble for a pass. You look at it and they say, go by. Yeah. So time changes things. And that's an instance where I have no doubt it will become more acceptable because of the ease of use. So we've probably seen it already with facial recognition on cell phones and having them connect.
Right.
So that's one. So context matters. Second thing I would emphasize is have some perspective as to the collection of topics that have to govern our decisions on how and what to build with these things. So sure, privacy is very important. I've devoted enormous amounts of effort to thinking about it and trying to get it right. But also we want to succeed quickly in scientific endeavors to learn causes of cancer and such things. So there's a balance, and we have to keep track of the balance across different issues. So I'm known for saying ethics is not enough. And I think that's true. It's not just ethics. It's what can we do with these systems? How much benefit can we provide to people? How much economic output? How much will that improve standards of living? Lots of things of that form all have to come together. That's why I say economics, politics, and ethics. Historical and fiction guiding us. And then finally, I guess the last point that I would say is, as viewers and listeners of this think about it, there's an awful lot of discussion about regulating AI. I think that ignores context. I'm very much in favor of useful and thoughtful discussions on regulating anything that can affect lots of people in various ways. We have reasons to protect people and institutions and build fair economic systems and such. But it's not about regulating AI. It's about regulating the use of AI in particular domains. So I've been on the record of saying that. I think that while it may be occasionally that we could consider regulating AI for something that might come up, it's generally the case that we have to think about the application of AI. It's overwhelmingly the big problem. So I sort of am on the record at some risk to myself, I think, to saying that the regulate AI discussions are kind of the wrong way to go about this. We should be thinking about this contextually and all the meaning of the word context that I described. So that would be my conclusion for this, and I would love to hear from your readers in any way, or listeners and viewers if they have disagreements, because I have a lot to learn still.
Yeah, no, that's great. I think, yes, I totally agree. Context is important. And I was even thinking in terms of other things in life. You can look at the situation without context and make your own conclusions, which may be totally wrong. If you have the whole picture, then it makes more sense for maybe what people are doing or whatever. So
I agree completely.
Yeah.
Yep.
Yeah.
Well, thank you for your time. I appreciate it. It was very nice to be here with you. You're a great interviewer. Thank you so much.
Yeah, absolutely. I enjoyed very much this conversation. You have a lot of information and wealth of knowledge. So I really hope everybody will enjoy. And
I guess I could put a plug in for three things. So one is there's a good article in the ACM, the Association of Computing Machinery, February issue of this year by me on called this 3-part framework for how to apply data science and AI effectively. And second, there's our book, Data Science in Context, and that's available from Cambridge University Press, anyone that sells books. And it won a sort of major award for 2023 in computer science. And you can also download the author's manuscript from the datascienceandcontext.com website. And then there's a summary of that in the Harvard Data Science Review in July of this year.
Yeah, I think I have those links. I will add them to the description as well, so people can access them. Yeah. All right.
Okay.
Thank you very much.
Thank you very much. Have a great day.
You
Glad
too.
to be here. Bye.
Bye.